Science is about discovery, and it's really driven by curiosity. What if we could create a digital twin of an athlete and use that to help an athlete avoid a hamstring tear before the Olympic trials? Or use it to help a girl in high school avoid an ACL injury in her soccer game? Heal muscle, tendon, ligament, and cartilage very rapidly and restore its function. That's really the dream, to enable people to live stronger, healthier, more fulfilling lives. The mission of the Tsai Human Performance Alliance is to discover the fundamental biological principles that govern human performance. The Alliance is a public-private partnership involving 6 institutions: Stanford University, Boston Children's Hospital, University of California, San Diego, University of Kansas, University of Oregon, and the Salk Institute for Biological Studies.
Being athletic and understanding the value of athletics on human performance is something that we value as a family. And what has really surprised me is really the lack of advancements in the areas of healing and training regimens, largely due to underfunding in this space. When we noticed that there was a gap here, we convened a number of luminaries in this field, and we brought them all together to really examine, what the biggest issues were.
We have a group here of high-performing folks, and we're all in the same place, driving towards the same mission. I'm bringing the athlete perspective. What do people who are insanely fit and high-performing do, and what can we learn from them? Specifically, the University of Oregon will be focused on regenerative rehabilitation, and we're going to be using the Bowerman Sports Science Center as an innovation hub and applying some of the findings here directly to track and field athletes.
One of the aspects of this initiative that I like is the Female Athlete Center. There really hasn't been any attention paid on making sure that there was equal representation.
So much of research in medicine, and particularly in sports performance, has been based on men. We're addressing the needs of pediatric girls. We're looking at young women, masters athletes, and transgender female athletes as well. This work is so important as we see that women are staying active throughout their lifespan.
Diversity is incredibly important to our ultimate success. Everybody's included, everybody's welcome. One of the things I've been excited about is the collaboration with UNESCO.
UNESCO is in the United Nations system, is the institution that is dealing with education, culture, with science, and with sports to improve the well-being of people. All of us have this commitment to leverage the power of sports as one of the most important areas to advance.
Almost all of what we know about human health is from studying disease. We want to flip that and study optimum human performance to discover these basic biological principles that enable human performance.
Over time, I think we're going to get great researchers, and we're going to have great dissemination of information because we are working together in a global way.
We want to enable scientists throughout the world to build on the work that we're doing. Everybody jumps on. They want to be part of this. When we uncover principles that govern optimum performance, they're applicable to everyone. Open science is the way to do science. All of our discoveries, all of our software, all of our data will be freely available to everyone.
This is something that hasn't been done with this thought power behind it.
This is a once-in-a-lifetime opportunity.
It feels incredible because this is a real holistic approach.
We're doing this in a moment where humanity is searching to rebuild itself.
To understand human performance at a big scale with all these partners at all these institutions is really a dream come true. Thank you for joining us today to be part of the launch of a truly groundbreaking collaboration for the world, the Tsai Human Performance Alliance. My name is Scott Delp. I'm a professor of bioengineering at Stanford, and I'll be your MC for the next hour. On behalf of the entire Tsai Human Performance Alliance team, I welcome you to this event. Performing at one's peak physical, intellectual, and emotional capacity is a universal human aspiration, regardless of gender, ethnicity, or age. I'm excited to embark on this journey with an amazing team of scientists to gain deeper understanding of the scientific principles of attaining and sustaining peak performance, a key to helping all people thrive throughout life. Now, we are here because of the vision and deep scientific exploration spearheaded by Clara Tsai, and for the transformational gift from Joe and Clara Tsai Foundation. Groundbreaking scientific endeavors require bold visionaries, and we're grateful to Clara and Joe's leadership and generosity. It has been personally inspiring for me, and I know for the other scientific leaders, to co-create this alliance with Clara Tsai. And we're pleased to have Clara and Joe joining us today so they can share more about their vision for the Human Performance Alliance. Clara?
Thank you, Scott, and thank you everyone for joining us today. As some of you know, I like to support basic science research to discover new knowledge. I especially love new knowledge that has a direct impact on humans and society. Basic research connected to translational work really has been the philanthropic focus for me for many, many years. I also like to operate in white space, and in one of my worlds, a world of young athletes, my kids, aging athletes, including my husband, elite athletes, the players on our professional sports teams. In that world, I can see that there's a gap between the tools and methods that we have today to address performance, injury prevention, rehabilitation, and what could be possible if we applied the latest technology and tools and deep scientific rigor to this field. So from that kernel of an idea, we gathered 12 thought leaders spanning the fields of molecular and cellular biology, orthopedic surgery, bioengineering, computer modeling, professional sports training, and regenerative medicine. And we convened this group in La Jolla, California in February of 2020. And over a 2-day session, the attendees generated 57 research ideas, which led to the 4 priority projects, which are the basis of this Human Performance Alliance. So the Performance Alliance is a scientific collaboration among 6 major institutions aiming to transform human health on a global scale through the discovery and translation of biological principles underlying performance, and not just for elite athletes, but for developing athletes and for aging athletes, and really anyone with a body who wants to function at their peak, which frankly is all of us. This alliance in its entirety really represents a lot of what is important to me. Public-private partnership, basic science that will yield new knowledge, a built-in translational component that will impact humans, and also equity in the form of open access to papers and models, and also the Female Athlete Center, which will study gender differences in performance, which will have a major impact on the health of girls and women around the world. This is a very, very talented team. They have real camaraderie and a shared sense of purpose. We will all be building on each other's work. I'm really excited that you'll get to hear from many of these leaders today. But first, I'm going to turn it to Joe to say a few words.
Thank you, Clara. Clara still to me as an athlete, although I'm an aging athlete. I just remember when I played sports competitively in high school and college, your coaches and trainers are always telling you to trust your body, trust your instincts when it comes to whether you could perform at the highest level, whether it means they put you in the fourth quarter. You're listening to your own body. Well, that's good. I think most of sports is about intuition. We believe that we resources to making investments in innovation, in measurement, measuring how healthy your body is, rather than just purely listening to your own body. I think that's going to yield dividends. So I'm very supportive of this effort, with Clara spearheading this alliance. and bringing together the top academics, researchers, training professionals, biologists into this field. So I feel really excited to be part of it, to be able to support it. And I really look forward to all the folks on this Zoom call here to do incredible work, to understand peak performance, and to not only improve how professional athletes and peak athletes do on the field or on the court, but also to improve the lives of everybody. We want to be inclusive. So I feel privileged to be able to be here and support everyone. Thank you very much.
Thanks, Clara and Joe. I'm excited to share with all of you what this means to the leaders of the institutions that make up the Alliance. And we'll hear first from leaders of Stanford University and the University of Oregon.
By better understanding how the human body works at peak performance, researchers have the potential to spark new treatments for serious conditions and help people thrive at every stage of life. As a scientist, I'm excited by the incredible possibilities of exploration in this field. At Stanford, we believe deeply in the importance of cross-disciplinary collaboration, and I'm delighted that we'll be able to extend that strength as part of a team of teams alongside 5 other leading research institutions.
With these partners, we make a powerful team that will advance our ability to study peak human performance, with the goal of enabling all people to achieve health and well-being.
Thank you, President Tessier-Levine and Provost Phillips. We are grateful to all of our Alliance partners for their leadership in making this become a reality. And we'll hear from other institutional leaders throughout this event. So now let's dive into the first of our 3 scientific panels. And this first panel focuses on optimizing human performance for all people. And I'm joined today by 3 experts: Dr. Malene Lindholm from Stanford University School of Medicine, Dr. Andrew McCullough from the University of California, San Diego, and Dr. Sachin Panda from the Salk Institute for Biological Studies. Thanks to all of you for being here. And everyone joining the live stream, you're welcome to start typing questions for the panel on the right-hand side of your screen. We'll take a few audience questions at the end of each panel. And it's great if you think of a question, just enter it during the panel instead of waiting for the end. So I'll start with just a couple questions for the experts. And first to you, Malene, why study athletes? What are some examples of how this can help everyday people?
Well, we can learn a lot from the extreme. So when systems are pushed to the limit. So just as we learn from disease, we can learn from the other end of the spectrum. So people at the peak of human performance. And a classic example from genetics is Eero Mentoranta, a Finnish Nordic skier who dominated in the mid-60s. And in-depth studies of him and his family later revealed a genetic variant in the hormone receptor for EPO, which stimulates production of oxygen transporting red blood cells. So Mentoranta could therefore get a lot more oxygen out to his muscles, which of course gave him a huge advantage. And through him, we've learned a lot more about this molecular system, which was significant for understanding performance, but also have implications for people suffering from low levels of red blood cells, for example. And I think as we understand more about individual variability in different physiological systems like this, that will help us to provide more targeted treatments and eventually also exercise prescriptions to optimize the effect for each and every one of us.
That's really interesting. Yeah, I understand it's a great story. It's led to new medications that are now widely used for people who can't absorb as much oxygen as they need to stay healthy. So thanks for that. So Sachin, you're an expert in circadian rhythms, and every time we talk, I learn something new. There are a lot of factors that affect performance: sleep, diet, training history. How do you untangle these variables?
Yes, Scott, you are right that sleep, nutrition, and exercise constitute the foundation for health and peak performance. and we are systematically testing how each of them affect performance. For example, we discovered that eating all calories within a consistent 8 to 10 hours window every day can improve physiology, sustain optimum metabolism, and brain function. We also find the same eating pattern combined with healthy nutrition can improve sleep, sense of energy, endurance, and motor coordination, all of which are important for preventing and managing disease for all of us and for reaching peak performance and sustain it for elite athletes. As part of this amazing public private partnership, we will understand the biological mechanisms underlying how sleep, nutrition, and exercise affect health and peak performance. At the same time, in partnership with UNESCO, we are looking forward to translating these findings to everyone around the world.
Thank you so much, Sachin. Now you're at Salk, right next door to UC San Diego. Andrew, can you tell us about an exciting result from the Alliance that affects us all?
Thank you, Scott. In the past few months alone, the Alliance investigators have already reported some really exciting new discoveries. And just one example from investigators here at UC San Diego, where they have developed a novel way of using magnetic resonance imaging to reveal the cellular nature and the severity of skeletal muscle injury. And this greater detail and precision should help clinicians and trainers to make more accurate decisions about whether an athlete is ready to return to play or needs more time and rehabilitation.
Yeah, obviously super critical to know when it's possible to return to life, return to play, return to sport, return to 50 or 100%. So just a question for the whole group. There's a lot of new capabilities from wearable sensors. How do you see those playing into your research and the research of the Alliance?
So this is a really exciting and rapidly growing area, Scott. As you well know, we can now collect new continuous non-invasive measurements of human performance, physiological vital signs, and even body metabolism, such as blood glucose and ketone levels. And this unprecedented volume of new data is really allowing us to use AI and simulation to predict other important parameters that can't be measured directly. Your own colleagues at Stanford, for example, recently showed how smartwatch measurements can actually be used to predict clinical measurements from blood tests. And I think these new algorithms and simulations will also allow us to use these data to predict future events, such as the increased risk of overtraining or injury.
Yeah.
Yeah, there's another example of wearables and its impact from our own circadian rhythm field. For example, almost for 20, 25 years ago, people discovered that peak performance, athletic performance actually is at its peak in the late afternoon or evening. And that led to further research showing that, yes, our body physiology is at its peak. Our risk for injury is also at minimum in the late afternoon. But then only recently, a couple of years ago, circadian rhythm researchers partnered with wearable and metabolism research to put continuous glucose monitor on people with type 2 diabetes and put them on an exercise regimen. And what we discovered is amazing because type 2 diabetics who did high intensity interval training in the morning actually saw their blood glucose level increase and remain increased throughout the day through the CGM. Whereas the same individuals, when they exercised in late afternoon, they could successfully reduce their blood glucose, both morning blood glucose and throughout the day, their blood glucose remained low. So this is a clear example of how continuous glucose monitor, a widely used now wearable, can help everybody manage their blood glucose optimally.
Fantastic. Every time I hear from you, Sachin, I have to adjust my daily schedule. So thanks for that. Malene, any comments on the new technologies, wearables, how that might affect research you're doing?
Yeah, no, I completely agree with Sachin and Andrew. I think this is very exciting. And I'm personally especially excited to be able to combine the continuous data that we can get from wearables, and wearables keep developing. So we keep getting more and more different types of of physiological data, and to be able to combine that with both the imaging data, there's a lot of plans for it within this alliance, and also the molecular data that we're hoping to generate from different musculoskeletal tissues in athletes. I think it's going to be very exciting to be able to combine this through AI and machine learning.
Yeah, the questions now coming in from the audience. They're coming in on my phone here. So Dr. McCullough or any of the panelists, how does the Alliance plan to bridge basic science research to translational work that will impact communities and athletes?
Thank you for asking. That is really an important goal of the Alliance, which is highly interdisciplinary from basic science all the way through to translation, with the goal, as Clara has pointed out, of really having an impact on athletes and everyone. And so in order to bridge this gap between basic science and translation and practice, one of the strategies that we're using in the Alliance is to develop detailed computational models and simulations that synthesize the biological principles with the measurements in order to be able to make predictions and to understand the mechanisms by which changes in things like diet, sleep, and training affect performance.
Yeah, fantastic. Sachin, do you want to comment?
Yeah, so I guess Clara's vision actually was to combine basic and translational research. And as a result, we do have innovation hubs, which will immediately take basic science research and try to translate, optimize, and then disseminate to the public. At the same time, the Alliance also has communications integrated into it so that some of these findings that are applicable immediately to the general public can be disseminated. We will partner with various organizations, sports organization, physiology, heart association, etc. And most importantly, we are also partnering with UNESCO, which has footprint in over 180 countries. So this way, the Alliance already has a framework, very strong framework, to do basic science research and also translate responsibly to the right audience.
Awesome, thank you. You know, we've got over 500 people watching, and now I'm getting a ton of questions. Rocky Tuan just asked one, a world leading in regenerative biology, but I have to close this panel because we have two other panels. I love working with all you all, and I appreciate you being here for the panel.
Thank you, Scott.
Thank you.
Yeah.
Thank you very much.
Now let's hear from the leadership from UC San Diego and the Salk Institute.
With the Alliance, we will develop dynamic, multi-scale computational models from molecules to physiological systems, all of which are derived from novel scientific and clinical measurements. This model for discovery and dissemination of knowledge has created a global hub for innovation at San Diego. Expanding these synergies, we will apply new knowledge on the scientific principles of performance to benefit the health of all people everywhere.
The goals of the Salk and the Human Performance Alliance are well aligned. Their mission dovetails precisely with our researchers' continued efforts to transform human health on a global scale. This collaboration will benefit the scientific community by enabling deeper understanding of principles that allow athletes to attain and sustain peak performance.
Thank you, Chancellor Khosla and President Gage. For me, as a scientist, to hear university leaders talk about multi-scale biological modeling is quite exciting. So now we're going to move to our second panel, supporting performance and health of female athletes. And I'm joined by Dr. Kate Ackerman from Boston Children's Hospital, Dr. Nicole Keith from Indiana University. She's the past president of the American College of Sports Medicine, and Dr. Emily Krause from Stanford University. Thank you all for being here. Thanks also for the audience. Great questions coming in. I'm trying to get to as many as I can, but let me launch quickly first to you, Dr. Ackerman. What are some of the unique challenges faced by clinicians, including yourself, treating female athletes and researchers studying female athletes?
Well, there's so many. It's why our work will never be done. If we start with, say, the perimenopausal or postmenopausal woman who wants to stay active and wants to know how to keep on muscle mass, how to stay strong and stay really involved in her sport. We talk about a female athlete who is getting pregnant and wants to know how much she can exercise during pregnancy and how pregnancy will affect her. We talk about athletes who want to know how their menstrual cycle will affect their performance. So many of these questions haven't been completely answered, and they're very hard to answer because they take a lot of time, a lot of resources to really study the menstrual cycle in these women.
Great. Other challenges, Dr. Keith?
Sure. So one challenge is that it's important to remember that girls and women at different life stages are very different. So if you're looking at a little girl compared to an adolescent girl, compared to the other stages that Kate mentioned, they have to be treated differently. And so it's really important to remember that children aren't small adults, girls are not small women.
What about, let's dive into one of these challenges a little bit more. What are some of the solutions that are emerging? Anybody want to jump in?
Yeah, I can chime in. I think one of the challenges, especially as a sports medicine physician who sees these female athletes who present to my clinic with an injury, the question is how could we have intervened sooner? What are those risk stratification tools? And unfortunately, as Dr. Ackerman had mentioned, there is a large research gap, and I think it starts by finding out, asking the right questions, and then studying them thoroughly, and really taking into account some of these nuances within the hormonal cycle, and that changes, as Dr. Ackerman had mentioned, from adolescence to a collegiate, post-collegiate athlete, premenopausal, pregnant athlete, and we really need to dial in and really understand those questions and take it to that next level. And I'm sure Dr. Ackerman and Dr. Keith can really talk about some solutions in more detail as well.
Yeah, great. So Kate, just jump in. What are some of the things you're studying, exciting findings that are actually beginning to get translated?
Yeah, so I think one of the things all three of us are interested in is bone stress injuries, stress fractures, female athletes. We see these a lot, time and time again. And so we might see a female athlete who's not eating quite enough for how much she's exercising, inadvertently or not. And then she has menstrual irregularity, and that correlates then with her being at a higher risk for a stress fracture. Then once she has the stress fracture, how are we getting back? How are we improving the nutrition? How are we improving the bone density? And how are we returning her to activity? And so we've done some studies looking at bone density and bone quality in stress fractures. So for example, with tibial bone stress injuries. And what was really interesting to me as a clinician is that we found that over 12 weeks, the bone microarchitecture actually got worse over those 12 weeks while we were trying to rest the person and then bring them back to activity. As a clinician, we usually think that by 12 weeks, you can get back to running. But what we saw was that that bone needed to recover. So here's a great opportunity for us to determine how much loading should we be doing? What kind of rehab can we be doing? Should we be doing partial weight bearing to get these people back to their activity so they don't have yet another injury?
And Scott, I'm going to just jump in because as the non-physician on the panel, one of our concerns is about access to care and meeting girls and women where they are and getting into communities to make sure some of these problems are invisible until they become very visible and problematic, and making sure that there is a prevention going on with these women so that we can avoid injuries, but making sure that we're getting to them where they are and not waiting for them to go to the physician.
And Dr. Keith raises a very good point. One of the alarming statistics is that girls drop out of sports at a rate of 2 times versus boys by the age of 14. And I think a lot of that is related to access and resources. And Dr. Keith is a physical activity researcher. So I think really understanding how to encourage and promote physical activity through those resources is really important to getting to the solution.
So one of the challenges is that some research findings don't make it into the clinic or onto the playing field. And I'm wondering how we can translate these new findings, like Kate, you're saying about maybe pure rest isn't right. There needs to be some loading so you don't get the absorption of the bone. How do we translate those findings out to the clinic and to girls and women?
Well, I think we have a lot of opportunities for that. We started a female athlete conference in 2013 that we do every other year. And that was really to have a forum to bring researchers together so they could come up with ways that they could collaborate, but also to get that information to the athletes, to the coaches, to the parents, to the other physicians that aren't studying this. And so we've been doing that for a while, but I think now we're even getting more accessibility with social media and making sure that we have online platforms. And I think Emily can speak about that.
Yeah, one of our big initiatives, thanks, Kate. One of our big initiatives is to create a platform to translate all of this important research coming from all of you on female athletes and performance, where athletes, coaches, parents, practitioners can get the latest cutting edge information to enhance the health and lives of women in sport. For example, menstrual cycle and that topic, as it relates to injury and performance, can be really confusing and challenging to interpret for an athlete or for a coach, a strength and conditioning coach, to really prescribe the best exercise for that athlete during different stages of their cycle. In addition, and we're also covering a lot of fueling strategies and talking about the importance of nutrition and fueling to really set yourself up for success to reduce injury risk and perform well.
I love that combo. It's not just reducing injury risk, but you've been teaching me that stronger is faster, not lighter is faster, and I think that's a key message. We have a bunch of questions coming in from the audience. I'm going to ask them now. So Bev Smith asks, is there an opportunity to understand and study the effects of childhood activity on future health performance? For example, building bone health early. So Dr. Keith, you want to take that one?
I sure will. And not only is there an opportunity that's being studied, it needs to be studied more. We know that an active child who continues activity through adulthood reduces all kinds of chronic disease. And so it's really important to give opportunities to be physically active at a very young age, and then encourage and support that as girls and women grow.
Great.
Yeah, I think diseases like osteoporosis, I've completely shifted my thinking about that. I think of that more as a pediatric disease. We should be doing as much as we can to build the bone density of young kids and adolescents, because there's a window when they get to their peak bone mass, and it happens when much younger than you would expect, in the late teens and early 20s. So if we're getting these kids active, like Nicole is saying, that's really going to be the key.
And a lot of the preliminary research does support, in addition to nutrition, to help optimize bone health, but even in participating in different sports and multidirectional sports. And I think that is a really important area to study, is especially as sports specialization and over-specialization is becoming more prominent in athletes at that age.
So we have a question on exactly that topic. Thomas West is saying, hoping that this research could illuminate benefits, or more importantly, risks of all year, all the time youth sports activities where the season never ends. Could any of you comment about that?
Yes, I mean, there are people working hard to demonstrate that that is the case. I think if you talk to pediatric sports medicine specialists, we know this. These are the injuries that we see. We are constantly trying to compete with the clubs and the competitions who want kids to excel too early and not give them a chance to develop, get different, like Emily said, multi-directional activity, a chance to recover, a chance to really enjoy what they're doing so they don't suffer burnout. So we know from a pediatric lens that that's important, but we have to shift the thinking so that people will realize you will still be a really successful athlete later on if you're doing lots of different things at a younger age.
And really touching on all of these other aspects, that it's not just about the training, what you're doing on the field, on the track, in the water, but what you're doing on in the other time, that off season, that strength training, the sleep, the nutrition. And I think that there are so many of those topics being covered with the different institutions involved in the Human Performance Alliance. And I'm excited to see everybody dive into that.
I have to also revisit what Emily said earlier about it being fun, and that it's really important, especially for kids. It's about friends and fun, and that's why they're participating in the sport. And so it's really important also when we're talking about year-round to make sure that it remains fun. As the mom of 2 collegiate athletes, It's really hard to get them to do a different sport. They love their sport, but I want to make sure they're still having fun.
So yeah, one of the things that you all have pointed out to me is the link between mental health, behavioral issues, nutrition, and injuries, that they're all linked. It's scientifically very challenging to address and really does require a multidisciplinary approach. So happy to have you on the team. So another question from Adam H. I'll just read that out. An important part of successful clinical treatment and translational research is dependent not only athlete and caregivers, but also on the athlete's larger community. Do you plan to look at outreach and education efforts, especially for historically underserved communities?
So again, Scott, I do that now, and I plan to continue to do that. It is really important, especially in low socioeconomic status communities, that we understand schools have less resources, there are less opportunities for both boys and girls, but especially girls, to participate in sport. And that community involvement and that community access is incredibly important.
Yeah, I agree with Dr.
Go ahead, Emily.
I think we can all speak on the importance of this topic and making sure that all of this amazing research is getting translated and disseminated into the hands of the people and in the hands of the people that really need to hear it the most. And working with Dr. Keith and Dr. Ackerman even on this platform to find ways to make sure that the coaches and different coaching organizations have access to this, to that, and to the parents too. I think that's a really important piece of this.
Kate, we have just one final minute here, and I'm wondering, part of this translation, you've really spearheaded the Female Athlete Conference. I wondered if you could talk a little bit about that, what some of the latest discoveries that you just ran that conference last month, and what were the exciting new results?
Well, I think one of the things that was really exciting and surprising to us through this pandemic was how much we can connect with people over Zoom. So this was the first time we did our conference virtually, and we had people from 32 countries. We had people from 40 states in DC. And what it really did was establish more collaborations. So a lot of the people that I do research with, I've met through various organizations like the American College of Sports Medicine or with this conference. And so now we have people working on the same problem together. So colleagues in Australia, in the UK, in South Africa, and in Canada, wanting to study different populations from different backgrounds with different experiences, and looking at, for example, one issue, the menstrual cycle. So how does the menstrual cycle affect performance in a soccer player in South Africa? How does the menstrual cycle affect performance in rowers in Canada? So a lot of this is really just getting the right people in the right room, whether it's a virtual room or it's an actual room, and having these minds come together to really attack those questions. And a lot of that was focused on at the conference.
Emily, I know you attended. What were highlight research finding for you from the conference?
I think that the interdisciplinary component of building a female athlete program was really emphasized at the conference. For example, there were speakers from backgrounds from dietetics, from mental health specialists, physical therapists, and all of those pieces are really important to deliver the best care to a female athlete, and they can all contribute really well to provide the best care head to toe. And I think one of the other unique aspects was this coaching perspective that really came forth within the Female Athlete Conference. So a lot of coaches attended, and they were really eager to learn. And so finding ways to kind of speak that language of the coach, which is a little different than the patient or the parent or a physician or colleague. And I think that's a nice reminder to us all when we are sharing this information out into the world.
It's fantastic. And I know the coaches care about performance and about winning and about getting the best athletes to participate. But I think your ability to show that performance and health go together, and resilience of girls and women who are performing, I know it's an issue here at our university, and I'm sure it is everywhere. Dr. Keith, last comment goes to you. Anything you want to say to the hundreds of people listening at this moment?
Sure. I just want to talk about the power of social media in good ways and bad, and that lots of girls, especially, are getting their body image from what they see in social media. They're also getting their science from social media. And so it's really important for us to continue to push out information that is accurate, that's based in evidence, so that we can kind of help these girls and women understand what the truth is in terms of performance and in terms of health and in terms of their body image.
Thank you so much, all of you, for all those thoughts. You know, one of our biggest mission here in the WUSA Human Performance Alliance is to be an authoritative voice for a true scientific information that can guide, and really appreciate all of your leadership in making that happen. Thanks so much.
Thank you.
Thank you.
See ya. Talk to you soon. So now we are going to hear from leaders at Stanford University and the University of Kansas.
This is a fantastic opportunity to apply Stanford's culture of innovation and interdisciplinary teamwork to the goal of improving human health for people of all ages and all physical abilities. The Alliance's 6 research institutions will form new collaborations. They will understand what goes right when athletes perform at peak levels and use what they learn to help people everywhere live to their fullest potential.
Our scholars will provide valuable insight on how to train, coach, and optimize sport performance, working directly with athletes and coaches. Through the Alliance, our lab will be able to greatly increase student research and engagement opportunities in the flourishing discipline of sports science.
Fantastic. Thank you, Dean Moeller and Provost Beckelmeyer. And a special shout out to Professor Andrew Fry at the University of Kansas, who's leading their outstanding program. So now for our third and final panel, we're going to focus on accelerating recovery from injury. And I'm joined today by 3 world-leading experts: Dr. Robert Goldberg from the University of Oregon, Dr. Martha Murray from Boston Children's Hospital, and Dr. Michael Longacre for Stanford University. Thank you all for being here. I know this is going to be a great session. And I just want to kick it off with a question for Dr. Murray. From a clinical perspective, what are the major challenges in treating common injuries for athletes at all levels?
Well, that's a great question, Scott. I think one of the major challenges we face as clinicians is that we often don't have a way to measure how an injured structure or a structure that we're trying to train is actually doing. So for example, if a teenage girl is playing soccer, we don't know how much soccer is going to make her ACL maybe stronger or how much might make it weaker, and we have no way to monitor that. Similarly, after we do an ACL reconstruction for a patient, we can't really tell how the graft is doing. So we decide on return to play based on things like the strength of the leg or the knee motion. Without knowing exactly how those injured structures are doing, it makes it difficult to optimize either training protocols or rehabilitation protocols. So something along those lines would be incredibly helpful for us as clinicians.
So, Bob, one of the moonshots for the WUSA Human Performance Alliance is the regenerative rehabilitation moonshot. You're leading that. And can you tell us what that is and why physical rehabilitation and regenerative biology need to be considered together?
Yeah, thanks, Scott. You know, regenerative rehabilitation is really an integrative approach to injury management that recognizes, despite the fact that we've made great advancements in surgical procedures, new regenerative therapies like stem cell delivery and rehabilitation, none of those alone may be sufficient to completely restore function following an injury. And moreover, there's increasing evidence that the combination of regenerative and rehabilitation strategies can be greater than additive. In other words, 1 + 1 can be more than 2 in terms of the patient's recovery by really understanding the principles of how to optimally combine them.
Fantastic. Dr. Longacre, why don't we regenerate? I mean, we rupture a tendon, rupture a ligament, tear a muscle, and we heal imperfectly. It's not as strong, it takes too long. Why don't we regenerate, and what can we do about that?
Well, thanks, Scott. It's a big problem. Scarring is a late evolutionary event. It's a rapid restoration of the body, but it compromises in many situations form and function. So I think it's a speed to survive and procreate at the expense of carefully recreating things. Now, we do have tools and breakthroughs that really raise the specter that this is indeed possible. In the spirit of discovery and then translation, we now know that everyone on this call healed without a scar in your first 2 trimesters if you're injured, and then you transition to scarring late in gestation. So for the first time now, we are able to get wounds to heal with true regeneration without any scar formation, normal strength, all dermal elements coming together. So that's a significant breakthrough in animals, now moving in the spirit of translation, as the WuSci program is talking about, into large animals. So it's definitely possible now to do that outside of the maternal ICU, so to speak. And I think that would be great for all athletes and citizens.
Fantastic. I guess I just want to have all of you look forward 5 or 10 years, and what exciting developments should we expect over the next decade? Martha, you want to take that?
Oh, sure. Yeah. So my hope is that, right now there's a fair number of musculoskeletal injuries that we treat surgically by removing the tissue. So a meniscus tear, we just have to take out the meniscus or part of it. The ACL, we take it out and replace it with a graft. My honest hope is that we'll be able to restore those tissues rather than having to remove them and replace them.
That would be great. Bob, what do you see as a home run here?
I think through this combination of discovery, fundamental, and translation, I think we'll understand more on a patient-specific and injury-specific basis, what is the optimal combination of treatment and rehab. We know this combination makes sense and there's synergy. For example, our lab has recently shown that the timing and the intensity of the local mechanical strains during rehab dramatically affect your genes that are expressed, the revascularization. And so, I like to think of rehabilitation as a mechanotherapy that can be as potent as any medicine and can really be, as Michael was saying, the difference between fibrotic non-functional repair and full regeneration. And what we need to do is really understand what are these windows that are optimal and be able to apply them in a real-time, patient-specific feedback manner. So I think that's where we'll get.
Go for it, Mike.
So we were fortunate to identify mouse skeletal stem cells and human skeletal stem cells in the last 5 years. So a single cell type gives rise to bone, cartilage, and spongy bone. And to what Bob and Martha are alluding to, we've now taken that basic tool and said, oh, can we coach these to regenerate something like cartilage, which has no blood supply and doesn't heal? And the answer is yes, we can do that even in aged animals. We can do it in arthritis. So that's moving into large animals. Secondly, can we use that to understand osteoporosis and osteopenia that happens as we age? And the answer is yes, the skeletal stem cell does participate in that. So these fundamental building blocks can be used to then say, okay, let's not repair with scar. Let's regenerate our native tissue. And I think we're having the building blocks to do that. I do want to add that what Martha and Bob is saying is critically important. What those skeletal stem cells are feeling mechanically or whatever tissue is there is very different from how strong the quad is or the hamstrings are. So I think getting to the tissue that is regenerating and understanding what's happening in an implantable or some new image will really fast forward this. So that's what I look forward to.
Yeah, so you all pointed at this gap of knowing what the mechanical loads are on tissues and how that is a potent medicine for regeneration or not. And what do you see as the interplay between sensors, either implantable or wearable, in the regenerative biology space? Martha, you want to jump in?
Sure. I mean, I think it circles back to what I think we've all been saying, but if we had some way of measuring how the tissue of interest is responding to the mechanical stresses that are being put on it through rehabilitation, that way we could really tune those rehabilitation protocols or training programs to optimize that tissue to make it stronger and stronger rather than having it broken down by our protocols.
Bob, what's up with wearables or sensors?
Yeah, I think it's going to go beyond wearables. I mean, as has already been talked about, wearables are moving at incredible speed. The sophistication of the type of data that we're getting for these athletes is just, exponentially increasing every day. One of the things that we're really excited about at the preclinical stage right now is we've developed some completely, battery-free wireless sensors that can be implantable. So implantables, if you will, that can provide feedback on the inside. So you can imagine someone has a fracture or an ACL reconstruction, and the physical therapist is actually getting real-time feedback of the mechanical environment during the rehabilitation process. And I'll also mention, I don't think it's just sensors. I think what you do, Scott, is incredibly important for understanding what that mechanical environment is, because what we're trying to study, human performance, is incredibly complex. There's way too many variables for us to rigorously test all of them, even if we had 100 years to do it. And so the marriage of experimental studies with computational simulations is so important. And the digital athlete that you're leading is going to really marry so well with all the experimentalists and the data they're collecting.
Thanks. Totally agree that we need to marry the experimental and the AI and the simulation. Yeah, I have a bunch of questions now coming in. This one actually came in from Professor Connie Chu, one of my colleagues at Stanford. It was for the last panel, but it's totally relevant here as well. What are some actions that can be taken to reverse osteoporosis? Bob, you want to jump in?
Well, I think certainly, first of all, understanding, as was talked about in the previous panel, what is the progress of the remodeling that's going on, and understanding the mechanics and how we're at risk for refracture is going to be really important. But clearly, physical activity is one of the components that's going to be key for maintaining activity. The problem with osteoporosis is, of course, that you're also at fracture risk. So again, it's going to be fine-tuning that physical activity to the right level that it's actually enhancing bone density, but isn't causing a potential risk of fracture to the patient.
There's another one coming in. I'll dish this to you, Dr. Murray. How might you use the principles discovered about regeneration to actually prevent injuries from happening in the first place?
Well, I think if we can figure out what signals would stimulate a tissue to regenerate, many of those same signals would be the same signals that would encourage the tissues to make more tissue or make the tissue bigger and stronger. So I think understanding regeneration helps us, and also understanding how to build tissues up so that they can take the stress that an athlete wants to put on them.
Okay.
Scott, may I jump in on the osteoporosis question? So one of the people that will be funded, my colleague Charles Chan and I have a paper coming out in Nature that explains osteoporosis through changes in the skeletal stem cell, and also talks about a local rescue to restore fragile fracture healing to normal, healthy levels. So again, these fundamental discoveries do have an important role to translate. I want to say that later today and tomorrow, there's over 900 people on an Howard Hughes Medical Institute in Janelia conference that's replace, repair, and regenerate, with the specific question, why don't humans regenerate? So the synergy of this program with other programs is actually happening today. And that just shows you the demand and appetite for people who want to be regenerated back to how they were, and not with a spot weld repair that kind of does it.
And Scott, if I could just add to that, one of the things that we've been really excited about recently is discovering that there's an immune component to all this. And a lot of what explains differences between how patients are repairing or are having fibrotic repair is their immune response to injury. And what's really been fascinating about this is some of the same responses we're seeing in non-responders to treatment are what you see in a cancer patient or an infected patient. And so there's a lot of crossover between these different fields.
Yeah, I saw you had that beautiful paper in PNAS a couple of weeks ago. I really enjoyed that. Okay, we have a question coming in from Rocky Twan. Rocky, I'm sorry I didn't get to your question last time, but this will be our last question for this panel. Bob, I'll dish this to you initially, and then Mike, you can chime in, anybody else. How do we optimize the interplay between intrinsic and extrinsic factors in regeneration? And with respect to fetal healing, is a key feature of the fetus floating in the maternal ICU, that is no weight bearing, or are there other factors to consider? So Bob, why don't you take that and then pass to Mike?
Yeah, great question from Rocky. Thank you for that question. I think this really gets to the patient specificity, understanding what that intrinsic regenerative capacity is, which, we don't exactly know how to measure that right now. It might be, levels of circulating stem cells, or it might be the vascular, the vascular situation for the patient, or their immune status. So understanding that, I think, will help us tune and again, do real-time feedback of those extrinsic factors, which could be a treatment or a rehabilitation protocol, in order to optimize it. It's really this combination, I think, that's going to be so exciting to explore through the Human Performance Alliance.
Mike, last quick comment from you, and then I'm going to have to close the panel.
Thank you, Rocky, for the question. It turns out that the hypogravid environment in utero doesn't play a dramatic role in how we heal. However, modulating mechanical responses in adult animals with a certain fibroblast population is the key. So yes and no is the answer. We can't get away from mechanics, which is a foe if you're driving SCAR, and a friend if you're at the right level for hard tissue repair.
Fantastic. Thank you all. Love to work with you. I'm glad that we're going to get to keep this going, and all these discussions many days long over the next few years. We will now hear from Dr. Kevin Churchwell, President and CEO of Boston Children's Hospital.
As a physician, I'm excited by the science the Alliance will foster, the research it will support, and the long-term benefits to women's health it will make possible. Researchers from across the United States and around the world will be able to pool their knowledge like never before to not only better understand human physiology, biology, and performance, but more importantly, to enhance lives.
Thank you, Dr. Churchwell. We'll now move on to a few closing remarks. Clara?
Thank you, all of the wonderful panel participants. I want to thank everyone again for joining us today. My hope is really that what it takes to perform better, to prevent injuries, and to recover from training and injury becomes grounded in science. And if it happens, we will really change the lives of athletes, but also everybody, right, in our daily lives. We want to turn human performance into a quantitative predictive science. And it starts with the knowledge that this alliance will create. So we want to help people thrive throughout their lifespan and prevent many chronic diseases. Defining the principles of performance will require a global collective effort. And so we look forward to engaging with all of you on this call and many others as the Alliance grows. So thank you.
Thank you, Clara. The Tsai Human Performance Alliance is absolutely going to be transformational for girls and women. Currently, athletic women are operating in a bit of a black box. So I'm excited to see what women can accomplish with sports and performance, basically sports and performance science tailored for their specific physiology. So if you're a clinician, a scientist, a coach, or an athlete, I hope you'll join us in working to close this gender and sex gap, basically allowing us to provide novel performance metrics to female athletes across the lifespan, making a beneficial impact for people, particularly girls and women worldwide.
I'm so excited to be a part of this group. This partnership will enable scientists to identify real-world needs from athletes, from coaches, from sports medicine professionals, but they'll need our help to do that. So if you're an athlete or a coach or a student who's studying sports medicine, neuroscience, bioengineering, or just has a passion to make a difference in human performance, your perspective and expertise is absolutely essential to the success of this mission.
We hope you're as inspired as we are about the possibilities and breakthroughs ahead. We stand on the shoulders of the creative scientists and innovators who have set the stage for the Tsai Human Performance Alliance, and we welcome collaboration from the research and academic community. Join us in our mission to harness the power of scientific discovery for the benefit of society.